255.255.255, which is broadcast. And the equivalent at layer 2 is all Fs, which is the broadcast. Okay. All right. The simulation is going to send the packet from the switch to all of the interfaces connected to the switch. And look what's happening at the router. Let's click the simulation button or the capture forward button again. Okay. Now this presentation was a little different than the previous one, right? The router did not forward the broadcast. So routers break up broadcast domains, okay? So if you want to keep broadcasts from getting to one network to another, then of course you want to use a router, okay? Basically a router is the way you would create multiple networks and connect them, okay? Which leads me to an interesting point that you need to be aware of. Each of these links is considered a network because they're connected to a router. Each link is also known as an interface. Okay? The rule you need to be aware of is no two or more interfaces on the same router can be a part of the same network. No two or more interfaces on the same router can be a part of the same network. i.e., if you have 5 interfaces on a router, all 5 of those interfaces must be a part of, or can be a part of the same network. They must be different networks. Okay? So on a router, you have 5 networks. If you got 5. If you have a router that has 20 interfaces or 20 ports, each of those ports will be on a different network. Okay? Unlike a switch, you can have a switch with 100 interfaces, and they can all be a part of the same network. How about a wireless router? Wireless router, such as the one you have at home, functions kind of the same way. The router, the device you have at home is actually a router and a switch. Okay? Because you'll have a WAN port on your device or an uplink port. That port is going to be on a different network from those other 4 or 8 ports. Those other 4 or 8 ports are considered switch ports. That's what, hence I said that device is a router and a switch. It's a router in the fact that it's keeping that WAN port on a different network from the switch ports. Okay? It's also a switch because it provides switch ports. And the wireless connections are on the router or on the switch? The wireless connections will be attached to the router/switch. Okay. So like every link that goes into a different IP address. If you're talking about a router, every port on the router is going to have a different network address, and I'll show you how it works. Let me clear this screen. You still have some that. Okay, you said I threw you with that, and I intentionally interjected this here because from this point on, you need to be aware of that because the class is going to be built on, in large part, that premise. You're going to be programming routers, and you're going to be creating additional networks, and we call it subnet. If you don't respect that rule, then you're not going to get the following assignments correct. Okay? All right, I brought out a router to the workspace, and this is the same router that we use in the classroom. All right? Let's see, this router has 2 Ethernet ports. All right? I'm going to configure fast Ethernet 0/0 with an IP address. And I'll say this IP address is going to be 199.199.199.1. And I'm going to give it a subnet mask of 255.255.255.0. Going to another interface, and I'm going to give it an IP address of 199.199.199.67. subnet mask. Whoa, it won't take it. What is it saying? It's, both of them are in the same network. So the router's saying, hey, you can't do that to me. You can't abuse me like that. I'm not supposed to function that way. Okay? So in order to make that work, then we're going to have to manipulate the subnet mask. And we saw, especially in this class, and maybe 2 classes ago, I showed you just by changing the subnet mask, you could change the network address, right? Okay, let's go back to fast Ethernet 0/0. Let's make this a 240 and go back to 0/1 and try that .67 and 240, and this time it takes it. No problem, because if we were to AND this subnet mask and IP address, we will find out that the network address is going to be 199.199.199.64 for this network. And if we were to AND the other one, we would find that this network is 199.199.199.0. Simply because we've changed the subnet mask. Okay? That's a very good question. Instead of changing the subnet mask, David asked, why not do this? Let's change this octet. So we got one there. Why not do this, right, David? Basically, what we did is change one value in that third octet. Now, that is a different network. So why don't we do that? The reason we don't do that is because it's because your IP addresses come from a hierarchical type structure. For example, your ISP will get a range of IP addresses from a body above it. And your ISP is going to be responsible for giving you your range of IP addresses, okay? So you're going to have the autonomy to configure the IP address ranges within your local area network. And your ISP is probably going to give you, for example, 199.199.199.1 or .0, and you can do whatever you want to with that network. If your ISP were to give you 199.199.198.0, then your ISP is giving you 2 network addresses. You may not be authorized to have 2 network addresses. However, you want to have 2 separate interfaces for your internal network. So how do you do that without changing the subnet mask of that of the only IP address range that your ISP gave you? Okay. Let me draw that on the board. It may not be it.
While you're drawing there, that's questions about packet tracing.
Okay, question about packet tracer.
Yeah,
Don't be too discouraged about how packet tracer scores your activities. If you're certain that you've completed all of the steps, then feel comfortable with it and submit it. Because sometimes, well, we've noticed in the past that packet tracer has not accurately scored activities. Now with 5.31, those problems may be fixed, but don't quote me on that. Okay. All right, we're moving forward. All right, let's see how a packet leaves a PC en route to a destination that's on a different network. How do we know that this PC is on a different network without looking at the IP address? It's on a separate router. Right. Yep. Okay. All right. The PC on the left here needs to send a packet to the highlighted PC on the right. The PC on the left has made the decision to send the packet to its default gateway. Why send the packet to the default gateway? Yeah, why should this PC, the PC on the left, send a packet to the default gateway? Right, it's the way out of the local area network. Okay. Now, how does PC1 in this instance know that the destination is on a different network? Right, it's going to do that ANDing thing. It's going to compare it's going to AND its IP address and subnet mask, determine the network address, and then compare it to the destination IP address. Hence, it will make the determination that that's a distant or remote network. So therefore, it will know it needs to send that packet to the default gateway, which would be the router. Okay. All right, let's take a look at this little activity. Okay, packet is going to leave the 192.168.2.0 network en route to the 192.168.5. Okay, the PC is asking the question, is this packet destined for a device on this network? No, it's done the ANDing process and made that determination. So therefore, it needs to send it to the default gateway, which is the first router. That router is going to ask the question, is the packet destined for a directly connected device? What that means is the network that the packet destined directly attached to this router? Is it one of these interfaces? No, it's not. So it's going to send it to another router. That router is going to ask the same question. Is the destination directly attached? Again, the answer is going to be no. The packet traverses to the third router, and yes, the destination network is directly attached. Okay. Yes.
So in theory, your information would bounce all over the world before this was testing the bid.
So in theory, the question is, in theory, your information could bounce all over the world right before it gets to its destination. That is the essence of a packet switch network. You could have a situation in which you could send 1,000 packets to the same destination, and theoretically, each of the 1,000 packets could take a different destination, a different route to the destination. Okay? Yep. And it'll work something like this. And